Thank you for tuning in. And this episode, we are going to talk about how to make an application available so that if it were to crash, it would continue to operate without interruption. In this video, we're going to leverage Kubernetes across multiple nodes to illustrate a way to do this. And with us today, I am Mac Nethkin. I'm the Director of Consulting at Avoxy Consulting, and I've got with me our Kubernetes expert, Ryan Grelk. So with that, I'll turn it over to you, Ryan, and take it away.
In this demonstration, I will show you a simple YAML file that contains both a service and a deployment. The service will allow us to access this application via a load balancer, and the deployment will deploy our application from Docker using the great little Hello Kubernetes application from Paul Bauer. So as you can see here, I have my single Kubernetes YAML, Hello Kubernetes YAML. This includes the service definitions, what type of service this is. In this case, we're going to be testing it with the load balancer. And we're tying it together with an app, which, as you can see, as I highlight this, we're calling this application all throughout this YAML file. As I mentioned earlier, this is a deployment for the Hello Kubernetes application. Initially, we will deploy it with just one replica, but I'll show you how easy it is to scale that to multiple replicas in your environment.
There's an instance why I would want to have more than one replica in my environment.
You would need to have a highly available application. Maybe it's a database server or web page that you always want to be available for your end users.
So is a replica of one meaning there's no high availability, and a replica of two or more means I have the high availability?
Correct. So if one of those applications were to die, that second one can take over. Or depending on how you have a load balancer configured with ingress, which is another Kubernetes concept that allows you to automatically choose which pod being an application inside Kubernetes, which application that the end user would connect to automatically. So depending on how many nodes you have in your environment, nodes are essentially servers. They're called workers. These would allow you to automatically choose which application is going to be presented to the end user.
Okay. I probably should ask before, but who's Paul Bauer?
Just some random guy that I found on the internet.
Okay.
Yeah. The application's kind of neat. That's why I wanted to use this specific one. I was going to use like a normal web server, but this one shows you which pod that you're connected to and which node, which is handy for troubleshooting.
Perfect.
Yep.
All right, let's see this work.
All right, so currently I'll check my environment. So get pods. Currently I have no pods in the default namespace. Right now I'm going to deploy this into the default namespace. But if I were to deploy it to a different namespace, I would either choose a new namespace or I can create one. So if I run my kubectl get namespace, we can see that I have a default namespace ingress, kube node, kube public, and kube system. Most of these are just service namespaces that contain pods within those nodes. And then next, if I want to inspect my nodes, I could run kubectl get nodes. And now we could see that I have 3 Kubernetes systems in my environment. I have control plane, which is kube1 local, which is the server that I'm logging into and running the kubectl commands. And I have 2 worker nodes, which are kube2 and kube3. All of these are running the same version of Kubernetes, which is fairly important. And they're all spun up from the same VM template that I created. So if I wanted to view which services are available, since we are deploying a service, I could run the kubectl get services. And as you can see, I currently do not have any existing services. So now I can apply my hello.yaml file. And I will apply that right now. So kubectl -f. I'm applying the hello.yaml file into this Kubernetes environment. This YAML file has definitions for my service and deployment, along with all of the settings that I've configured with it. So if I apply hello.yaml, we can now see that a service has been created and a deployment has been created. So now I can run kubectl get service again. And now I can see that hello Kubernetes is available via a cluster IP at that address. Inside the definition, I have the application is listening on port 80, but within the actual nodes, it's listening on port 3655. So now I can run get deployments. So kubectl get deployments, and I see that I have one deployment available right now. Hello Kubernetes. It has one of one applications and one available. And inside the YAML file, I set the replicas to one. I could describe the pod to get more information. So kubectl describe pods hello Kubernetes. And as you can see, we get a detailed result of everything that's involved in this hello Kubernetes. So the name is hello Kubernetes, and that's the actual name of the pod that it's running. Right now, I deployed it in the default namespace. If I wanted to, I could create it in its own hello Kubernetes namespace.
What's the advantage of the namespace? Give me an example of how you would use namespace.
So namespaces are great because it's essentially a way to sort and keep your resources in their own container. The similar analogy that you would see in networking is like virtual LANs. So
okay.
Yeah, that's an easy way to think about it.
Oh, perfect.
We could see that the node is currently running on kube2, which is one of my worker nodes. And we see that there's an app labeled Hello Kubernetes, which matches this. We could see that the application is running and it's available via this IP right here. If I wanted to check the output of the web application, I could run the command curl, which is essentially a web scraper that works on the internet, to that IP port 8080 directly to the pod container, and we get the output of the HTML file. We could see the titles set to Hello Kubernetes. The application says Hello World, and inside this HTML file that got created, we see that it has the title Hello Kubernetes. We could see that there's a Hello World in the main body. And then it also tells us which pod it's connected to and which node. And then what the application is from, which is Pulpower Kubernetes. And it's actually the version 1.10.1, which is the most recent version of the application.
That's all it took to deploy the application. And then you can do multiples of the application, all load balanced and everything.
Yeah. If you have everything else configured properly, then yes, there's a lot that goes into it being fully load balanced and accessible via the internet. Right now, we're working in our own lab, and we don't have external IPs that we could present. So if I type kubectl get pods, we see that there's only that one single pod. Kubectl get pods. Oops. Get nodes. That's fine. Now, what would I want to do if I wanted to scale this application? I have a couple options. I could go ahead and modify the YAML file directly. And let's say I want to scale to 3 replicas. With Kubernetes, all I need to do is apply this YAML file again, and it will notice that there's a change specifically in the replicas 1 now is replicas 3. So now it should notice that there's a difference in the current configurations, and it will spin up 2 additional replicas for us. So I'll go ahead and apply the hello.yaml. And we could see that the service was not modified, so it's unchanged, but the deployment was changed and it reconfigured the application. So if I go and check my deployments, we can now see that Hello Kubernetes is ready 3 of 3 with 3 nodes available. If I wanted to scale down, I could set it to 1. Apply that same file, get my deployment, and now we're down to 1.
That was quick.
Yeah, it's a small, fast app, so it's definitely going to be quick. If this was maybe a database application or a larger application, you know, those can take a lot longer to spin up, but this is just a very, very simple HTML server.
Okay. Actually, that's good information to know too, that apps aren't going to be necessarily that fast.
Yeah. No, good questions.
Mm-hmm.
If I wanted to set my replicas to 0, I could easily do that here. Apply the hello.yaml, and now we have 0 deployments. Well, what if I wanted to scale my application to 25? Well, I could easily do that either from the YAML file, or I could even do it from the command line. So if I type kubectl scale, oops, because equals 25, and then I select the proper deployment. So I want Kubernetes to deploy, to scale my deployment of deployment. Ooh. Hello, Kubernetes. So I'm calling the deployment up above right here. So I ran the Kubernetes get deployments, and the deployment that's currently available is hello Kubernetes. So now if I hit enter, it's going to scale to 25 replicas across both of my nodes. So hit enter. Whoop. It helps if I type it right.
And so by increasing the number of replicas, is that also increasing capacity of the application too, to handle and service more users?
Yes. Yeah.
Perfect.
So if we were to deploy this at an enterprise, we may want to set up auto scaling that may depend on CPU load on your nodes. So maybe if once a node gets to 50% CPU usage, you may want to spin up a new node so that you could deploy more pods. And all of that can be done automatically throughout Kubernetes, because Kubernetes is an orchestration environment that allows you to automate all of these functionalities.
Well, that's really cool, especially if you were in the cloud paying for CPU time. You're only going to pay for what you need when you need it.
Mm-hmm. Scale works both up and down, which is great.
I like that.
So now if I wanted to scale my application to 25 replicas, I could easily do that from the command line. And then I could watch the deployments. As we can see, here are the pods coming in. There we go. We're at 25.
That's really cool.
Yeah. So now I can do kubectl get pods, and each one of these pods has a specific GUID assigned to it. So if I were to maybe let's kill the first one. So kubectl delete pod, assign that pod. That pod's deleted. So we'll do a get pods. And as you can see, 2HXG4 no longer is in this list. And what's even cooler is it auto-created a running pod for us.
Really
Right.
cool stuff.
It is really cool. It's so complicated, but it's gonna get better and better.
So in the what do you mean by the complication? It's just because it's command line and some Linux code instead of like a nice fancy GUI, or
That, and there's a lot of prerequisites you have to get done and stuff like that. Obviously, if you're working in like Amazon, all of the prerequisites, those are already created for you. You could just start right away.
so AWS is already set up for Kubernetes natively.
Yeah.
What about Azure?
Yep. Azure has it. So does Google. Google created Kubernetes.
Oh, interesting. Okay.
Yeah. And they open sourced it. So now that we have 25 pods available, let's run curl against the Hello Kubernetes load balancer service to see what we get. So if I run curl against the load balancer IP, we can now see that there's a Hello Kubernetes application. If I go ahead and run it again, we'll see that these pods are different. So this is the way that the load balancer works for us automatically.
Oh yeah, so it jumps around.
Yep.
Different load balancers. So all right, so that's how you easily scale an application using Kubernetes. If you have any comments and questions, please be sure to leave those in the comment section below. And if you haven't had a chance to check out our podcast, be sure to do that. And thanks for watching.
Thank you.